University. And I'm glad and happy to be here today. After almost 3 years of COVID, I hate it, but I'm so glad that I made this trip and have this seminar. And I do understand that this seminar that you talk about very high power. You talk about, extremely high power. So we shift gear a little bit. We go to probably about 1 million watts because we deal with medical devices. Okay? So today, the topic for today is I want to focus on how to develop a wireless medical device. So Mr. Nghiem is the only Vietnamese person to have that kind of position at the FDA. And I'm so proud of him. And he gave us probably less than 10 minutes, but it's very valuable, and I appreciate his help. Taiwan University, I love you guys all. Okay, for many times that I know Director Dr. Huang, I know him well. Because he was a student in the United States. So yes, I love this school, and I'm glad to be here. So let me switch gear a little bit about the wireless medical device. As you know, if your heart has a problem,
in progress.
So as you know, if your heart have a problem, you need to have a pacemaker. So pacemaker will help you to live longer, right? But then we would like to use our cell phone to control our pacemaker in the way that if your pacemaker can communicate with your cell phone, and from cell phone can upload the data to cloud, iCloud. From that, we can analyze the data. And then that data will send to whoever physician around the world and control your pacemaker, fix your pacemaker, and save your life. So yes, we would like to have that wireless capability, but we don't want to spend a lot of power, a lot of energy from the battery. Because as you know, a pacemaker have to last like at least 7 years, and you have the battery this small. So if you want to use some energy out of that battery for BLE, for example, the Bluetooth, for example, you want to make sure to find a way to save the energy, to use the energy sufficiently. And that is not the easy job. That's extremely difficult job, and you will see why. So here is some of the projects that I have an opportunity to get involved. So you can see that a lot of implants. You can talk about the implant for deep brain implant. It's some sort of like a neural simulator that you have a small device can control your brain. If you talk about the cardiac, like ICD or pacemaker, that control your heart. And then you can have the insulin pump for diabetic people that it will send your blood. If your blood need to have some sort of, glucose or whatever, it will pump directly into your body. So everything from this, we like to do wirelessly. And that is the beauty of that. However, pros and cons, what does that mean? You have convenience, but then you have to watch out for other stuff. So I assume that you know what is a pacemaker. So in order to select a wireless technology, you want to make sure it have to be safe. So safety is the utmost important factor. So for example, I don't know that you know Mr. Dick Cheney. He is the former vice president of the United States. So he need to have some sort of like a pacemaker called ICD. And at the time I worked for Medtronic, is one of actually the biggest medical device company in the United States. At the time, we already have the wireless pacemaker for him. However, he rejected to use it because he afraid that someone out there will hack into the wireless communication and control his device and can kill him. So in order to have the wireless technology to implement on the wireless, on the medical device, safety is something that you have to think about that first. Security is related, right? So for example, you don't want to have anyone out there and capture and hack into your device and do whatever that they want to do. So security, we need to need to make sure that have that security. The most important thing, not the most important thing, like I mentioned it to you, battery consumption. Yes, we would like to have the convenience of the wireless system. However, we don't want to burn all the battery. Like pacemaker need to use that battery for 7 years. And now suddenly we introduce that wireless capability, and then the battery lasts only a few months. And that is not good. And I tell you, to design a system that to save the battery is extremely, extremely difficult. It's not an easy job. Reliability. You don't want to have your medical device, wireless medical device, hiccup like Bluetooth speakers. Sometimes you can communicate with your cell phone, but then sometimes you cannot, right? For medical device, it have to be reliable all the time, 24/7. And to design that kind of system, again, is not easy. No matter what you try to say, yes, Medtronic or Boston Sci or other company medical device, they want to design something save life, help people. But at the end of the day, they want to make money. One ICD can cost about $30,000. And that's just for the device. And then in the United States, if you have to go through the whole 9 yards to put that ICD in your body, it could go up to $500,000 easily. It depends on how complicated the situation is. So at the end of the day, I put it's cost effective, but it's really the key thing for the company want to get into something. At the end of the day, they want to make money. So to implement any wireless technology, these 5 factors, you need to keep it in mind. So this one of example that you see, this is ICD, similar to the one that Mr. Dick Cheney had. And you have the wire get into your heart. And let's say there's something wrong with the wire, you could not simply remove it because it's stuck in there. Okay? If you want to have a new wire, you put the new wire into your heart. At the end of the day, if you x-ray your heart, many, many wires. So that's why Mr. Sun Ting set the bar very high. At the FDA, you want to do anything with medical device, you want to make sure you have to test until that you say, please give me a break. How come that you guys want us to test way too many things, too many times? That is why. If you don't test your lead design, and at some point it breaks, you got a problem. And in the United States, we love to sue each other. Okay? So a lot of money. So the medical device. So here's a communication system that I did for Medtronic, probably 2004, 2006, so many years ago. This what we call the programmer. They use this big programmer is about $7,000 to control the ICD, to program, to get the data back and forth. This unit is at home. They call it a home monitor. So for example, if you have the pacemaker at home, during when you're sleeping, for example, suddenly your heart's, doing something funny, and will communicate directly to this home monitor. And then at the time that we have to use a telephone landline, we didn't have the Wi-Fi, like we do have like today. And this is another system. This is actually the another company called Boston Sci. At first, they use this frequency, and this frequency we call the ISM, stand for Industrial, Scientific, Medical. So in the United States, there is an organization, government organization called FCC. It will assign what frequency for what communication system. So this is something that everybody can use as long as you claim that you in industrial, scientific, and medical application, you can use this. So this frequency pretty similar to the frequency of your cell phone at the beginning. This is the frequency that actually Medtronic, they choose the wireless technology in the most expensive way. They come to FCC and they say, please give us this frequency. And we want to use this frequency for our own communication. That process takes many years, a lot of dollars, okay? So that's why today, people love to do this. Today, if you ask any medical device out there, they would like to use what they call the BLE, Bluetooth Low Energy. Why? Because we already have the transceiver, we already have the IC. You just go to different company that you can get the transceiver. You don't have to develop transceiver or IC circuit by yourself. So save a lot of money. And also, for example, iPad or iPhone or any phone out there right now already have BLE. So you see, they want to use your own cell phone, so they don't have to pay $7,000 for the programmer that we just talked about a few minutes ago. So now they want to use your own cell phone or iPad control your pacemaker. Okay, so that saves a lot of. That's why at the beginning I say one of the factors that you have to make sure that when you want to put the wireless technology on any medical device, it has to be cost effective. And that is the cost-effective way that I want to do it right now. There is a problem with BLE. You know how many devices out there that use BLE, Bluetooth? A lot, right? So if that's the case, we have to worry about the interference, right? Because your device medical device have to work 24/7, and suddenly that guy over there use cell phone with some sort of a BLE speaker or whatever, interfere with your system. That is a no-no. That's why the job for engineer to develop the BLE communication system for medical device is extremely, extremely difficult. Okay, so Bluetooth, everybody know, they claim that it's more power efficiency. It's not necessary, okay, for the medical device. Because if you use a BLE, it actually, most of the power of the battery in the medical device spent for the BLE, not for the therapy. So we would not say the power efficiency for that. But then a lot of data, security compared to the other wireless technology. And of course, a lot of people using this, so we have a good standard. And a lot of cell phone or iPads have the same technology. So it is a good choice, but here's a problem for BLE. An increased body loss at the IS frequency. Probably you already know the frequency of the microwave oven that you have at home. Exactly that frequency. The principle is, if you put enough electromagnetic power into the meat, into your food, you can cook it, right? But for medical device, we don't have that kind of power. But it's still, when you have the microwave at home, you using your microwave at home, that generates the same frequency, and that will interfere with your medical devices. So that's something that you have to keep in mind. And then you have wireless Wi-Fi system. Wi-Fi system use exactly the same frequency spectrum. And then a lot of people talk about wireless power charging system. You know what is a wireless power charging system? That you can have a lot of wireless device, and over there you have the station, it shine energy to those devices and it charge. But what does that mean? It's more interference for medical device, right? Because now this room become a lot of signal, and then suddenly I'm the guy that need to have pacemaker and get into this room. I got a problem, right? Because it will interfere with my pacemaker. Okay. You remember, I'm talking about how do we design a system that we can save power. A lot of people don't know that if this one is a cell phone, and a lot of cell phones have the antenna at the bottom and the top. If you hold your phone like this, the antenna further away, the antenna efficiency would go up to more than 50%. But if you hold the antenna like this and you do like this, the power efficiency can less than 0.1%. Why we care about, for cell phone, you run out of battery, you charge it, no problem. But for medical device, you cannot do that, right? So if you want to design a wireless for medical device, you want to make sure the way you hold the phone or whatever way that you have used that phone to communicate with your pacemaker, for example, it have to have a most effective way to deliver the power. So for example, here's the thing that you can see that I indicate a lesson to learn from self-user hand effective system performance. If you measure no hand around the phone, the efficiency is about 80%. Okay, so now if you hold the phone but don't hold the antenna, the efficiency go down to about 35%. But then if you hold the phone, you see now it dropped down. And then if you hold like this, about 5-something%. So if you want to use your cell phone as a way to communicate with your wireless pacemaker, you have to hold in the right way, right? You don't want to hold something like this and it won't communicate with your pacemaker. That is a lesson to learn. The first system that we designed for Medtronic called MIS, Medical Implant Communication System, used the frequency from 402 to 405 megahertz. Unfortunately, the surgical headlamp the surgeon want to use when they implant your pacemaker, as soon as you turn that on, it generates noise exactly at that frequency and interfere with the system. This is before we turn it on. Boom, when we turn it on. This is a signal. So as soon as Medtronic put that device in the market, a few months after that, Medtronic had what they call the Dear Doctor letter. What it means is that in the field, they have a problem with the system. As soon as doctor use that headlamp to turn it on, that we got a problem. So we have to fix it. This is a hospital RF environment for BLE. If you go to, let's say, hospital, and you have the spectrum analyzer, and you snip the RF signal, you can see at the hospital have a lot of equipment that use the same frequency for BLE, from 2.4 to 2.5 gigahertz. Same thing for the airport. Everywhere you go, you can see this. And then you remember we talked about wireless far field power charging system. That's a crazy thing. So our company, we don't do far field, we do near field, but we achieve what we call the wireless non-far field power system, and we have a very good system there. Microwave oven will give you a problem because it generates the same frequency. One of the things, even at the FDA right now, if you have the pacemaker, you have to consider, you have to concern about the lead, because the lead is long enough, it could resonate at the frequency of MRI machine. Normally, MRI machine, we have two MRI machine. One is 0.5 Tesla, and the frequency for that resonant frequency for that MRI is 64 megahertz. And the other one, very popular, 3.0 Tesla. The frequency for the MRI for that machine is 128 megahertz. So when you get into the machine and you have the pacemaker, you need to be careful, because that pacemaker has a long lead, provide a mean to capture energy from MRI machine. And then at the tip of the lead, it will heat it up, high degree, and then burn your tissue. You don't want that. You don't want that. You already have heart problem. You don't want to have that thing burn something in your body. So that's one of the things the FDA really concerned. In my opinion, that heating effect is just a secondary effect. Why? Because when you design a wireless pacemaker, you provide a really good mean to cap energy from the MRI. And when you have enough power to get into your pacemaker, it will destroy the electronic circuit. And I want to prove that. So don't worry about this. So this is the thing that I already did. So, and I don't want to name here, okay? If I name here, probably they go after me and sue me. So I just want to say this is an unknown medical device, wireless. Before scanning for MRI scanning, the signal looked very good. Right after that, you can see the signal look at a funny. And then 24 after that, 24 hours after that, you can see that the device kind of screwed up. I don't want to go through this. This is kind of boring. Okay. Sometimes you think medical device system is so hard to design, but sometimes you can come up with a very simple solution to make the thing better. So you remember when I say that if you don't know where's your antenna, sometimes that you hold your antenna, right? But here's a one way, just a simple cell phone case that have protrusion like this, force you to hold the phone at the middle. Very simple solution. Everybody can do it, right? Actually, this design that my son, he come up with when he was 14 years old. Okay, so this is very simple. And the next design that he did is actually, for this, for example, if you have a cell phone here and you have the wireless pacemaker here, your cell phone will see that implant device very clear because right in front of you, right? What happened if the cell phone in the back? That you don't have a lot of signal go through your body because your body will absorb all the energy. So the cell phone in the back won't see your device. If it won't see your device, if you get in trouble, it won't report to the system, you get into trouble. And here is the very, very simple solution for that. We can design a cell phone holder in such a way that we can shine the energy in one direction. What does that mean? We call passive. What it means is we don't have to plug that into any electrical outlet. Does not require any power. The only thing that we have to know how to focus energy in the direction that we want. Because for your cell phone, when you have this situation, the energy spread around. Okay? Now you design a holder behind that cell phone. And hey, I want to shine energy into that angle. All right. So for example, if you have the pacemaker like this, the cell phone behind you, right? And then you have the holder for that cell phone, shine all the energy, go through the body, and it will see your pacemaker. So my point is this, not because it's so difficult to design a wireless medical device, and we could not come up with any simple solution. Okay. Sometimes we can learn from that. So now this is for the medical device application. Imagine that so far that we use Wi-Fi, we spread energy around. Such a waste, right? So we want to find out, let's say in this room, we have 4 routers, for example. We don't care about the other part, right? We want to care a lot of people inside the room. We will have something behind that router, that base station, to shine the energy to where we want. So this actually, like that you did the design for the medical device, but you can apply to the different application, and probably that you will have much more people want to use it. So that is my conclusion for my presentation. Do you have any question that I can entertain?
Dr. Nghiem,
Yes.
may I raise one concern?
Okay.
The concern is not safety, not the reliability, but my concern that the security.
Yes.
Because the medical record of each person are secret, right?
It's
Yeah.
called privacy. It's called privacy.
Medical document for each person is secret. We are not allowed to see leakage or
Yes.
So when you use wireless, how can we protect the data of patients? That is security.
Well, for the security, of course, I'm not a security guy, but you have to encrypt all the data in such a way that no one can recover that. And I'm not a software guy, but that's something that people have to do. Because you're right, privacy in the United States, you don't do it, you get sued. And here, when you get sued, $1 million. So yes, it's called privacy. And then you can use the term security too. So people doing that, and the software engineer, those guys will help us to do it. Okay. And that is the key thing. You're right. That is something that if Chavin can do it, you're good to go. Because a lot of people concerned about that, even though that for BLE, it's very common, and they have the whole society organization to work on that privacy, but it's still, there is some loophole that some kind of smart guy but love to hack system, they get in there, they hack and they get the data, right? You know that, right? They hack your banking system, they get your money all the time, right? And now they have a lot of time off, they just want to hack into your wireless pacemaker. They can do it. But that is something that we need to emphasize, and I agree with you, privacy, security in that way. And we need software engineer to do it for us. And that is important. Yes. You have
Yeah, thank you very much.
Yeah.
Any question else, please? Thank you, Dr. Nghiem, for very nice introduction about very high technology. I'm very interested in the cost of the device because we want if people with low income can buy certain products. So how you can reduce the cost of your the products?
Oh, based on a lot of number of years that I work for a lot of company out there, my philosophy, if you do things right at the beginning, you save money. And here's the example. Before I joined Medtronic, there is a whole team to design the antenna for pacemaker and also for the programmer. They have about 10 engineers, 2 PhD, 1 master, and there's a few engineers. Spend million dollar for 5 years. At the end of the day, their design didn't fly, could not manufacture. Okay, so when I come in, I'm not the smart guy in the room, but what I did is I pay attention. Even that I have PhD degree, but I go down to production to talk to people at production. When I design something, I take the production difficulty or problem into consideration. At the end of the day, you have the solution very simple and save money. Now, that is just a way that you design, just an approach to the design. How do we save money to design for the wireless pacemaker, for example? You need to choose the right wireless technology. If you decide that you have way too much money, like Medtronic, spend million dollar, come to FCC, request a new spectrum, that is something that's too expensive, and you should not go that route. You go to BLE, that you can buy the transceiver a few dollars, right? But then you have to be smart. How do I design the antenna, use the BLE to save the battery? And yes, we can do it. And I do believe that university, Shaving University, you guys smart. We can work together. And by the way, I want to introduce Britain John Burns here. He's a director for the clinical trial, because for medical device, you have to go through the clinical trial, right? When you develop the wireless medical device, just medical device itself, it's not just a design, but you have to go through the clinical trial. You have to do the test on the animal. All those things cost a lot of money. And don't forget one thing. When you design something for cell phone, you don't have to have a lot of paperwork, documentation, but you just hear Mr. Nguyen Xuân thing for FDA, they request you test. And every time you test something, you have to have the document to back you up, and end up sometime the documentation, it costs more money than the way you design for the circuit, for example, or maybe for the design. So yes, a lot of things that we can work together, and we can find the most effective way to go there and save a lot of money. For example, I propose, this is my plan. Today I come here, and as you know that we find a way, and I do have the way to use the BLE to reduce the power, to design antennas such a way that we can save a lot of battery. We can work together as a team. You guys can test the system. You guys can do the clinical trial. You guys have College of Medicine, right? All those things that we can sit down, we can do it. And I'm so proud of Mr. Nguyen Xuân thing. We can learn a lot from him, because in order to have the medical device that we can sell in the United States, you have to go through the FDA approval. And I tell you, a lot of money. So sometimes people, I can design the cell phone. How do you design the medical device? Not just to design the circuit or the cell phone or medical device, but a lot of hoop that you have to jump, and that costs a lot of money. So we have to be smart. The question is, can we do it? I think we can do it. I think we can do it. Okay, so we can work together. And that's what I try to bring something to the Chavin University. See what we can do. Okay, thanks.
Thank you. Is there any question? My last question is, you know that now in Vietnam, there are many universities that they opened department of, for example, medical instrument to study medical instrument engineering, for example. Do you have any plan to cooperative with Vietnam University to develop your research field?
Okay, I tell you, that is really good field. And one of the things I already did for Chavin University, that I brought Dr. Tommy Swan from Columbia University. He is the top guy design the MRI scanner in the world. And Chavin University there is the name Chavin University in his center, back to Columbia University. That is one of the things that I want to do. I will get my guy over there, whatever area that I think that Chavin can enjoy in entertainment, we will work together on that. So I do believe that, you know, I'm proud to be Vietnamese, to be honest with you. I'm proud to be Vietnamese. So
yeah, thank you for your support.
okay, sure.
Yeah.
I will do all the things that I can do. Okay, thanks so much.
Yeah.
Bye.
Thank you very much.